here's another one that we want to sketch by transformation. And this one really hinges on remembering that e is a number. And it's one of those fixed constants. I'd call it a cousin of pi, not so much theoretically, but in the fact that it's one of those really, really important fixed constants that helps us describe the world around us. If anything, I'd say it's at least as important as pi to our understanding of the world around us, if not more. And practically, e is approximately 2.718. If I find it on my calculator, there's two different ways I can find it on my calculator. I can hit the second button and then divide here for this one, and I just get the number e. And the other way is if I hit the second button and the ln. ln stands for natural log, and it's log base e. And so e to the x is usually associated with log base e because they are inverse functions of each other. We haven't covered that yet, but that's why they're usually on the same key of the keyboard. And so if you only have that, you could do e to the 1, and that's going to give you the same approximation for e. All right, so since we know e is a number, and we know that it's important when sketching exponentials to know what the value of our base is, because exponentials look different, right? So I've got an a to the x, and a is not allowed to be 0, a is not allowed to be 1, and if a is between 0 and 1, it looks like one graph, and otherwise, if a is greater than 1, it looks like a different graph, right? And the basic sketch would be if a is between 0 and 1, its left-in behavior is infinity, its y-intercept is 1, and then its right-in behavior is a horizontal asymptote at y equals 0. And so LEB infinity, equals infinity, REB is 0 for the horizontal asymptote at y equals 0. And then if a is greater than 1, and y-intercept at 0, 1. Similarly, the base graph, if a is greater than 1, it still has that y-intercept of 0, 1, because anything to the 0 other than 0 to the 0, which is undefined, anything to the 0 is 1, which is, by the way, why we can't have a equals 0, because 0 to 0 is undefined. And so we still have the point, I'm going to put it over here. We still have the point 0, 1, but this time my left end behavior is 0, and my right end behavior is infinity. And so I approach the horizontal asymptote off to the left, and I explode with the exponential growth on the right. And so basic graph, that's the difference between the two. Now, since e is approximately 2.7, that places us firmly in. So e to the x follows this case. Okay, and so now let's go back to what are we actually trying to sketch. We're trying to sketch e to the x plus 1. So f of x equals e to the x plus 1. And so I know that's my base graph for e to the x. And then I just remember that this, because it's adjusting the input, not the output, is a horizontal shift because it's an addition. So addition implies shift works on input, not output. Well, I can say not output, but it works on the input, which implies horizontal. And remember, horizontal shifts, they behave backwards of how you expect them to. So a shift of +1 there to compensate for the +1 that's been added. My x values must be 1 smaller. And so I'm actually going to shift left 1 to end up at the same place. And so my sketch of this, it'll be that base graph on the right, but everything will be shifted left 1. And so where I was at the point 0, 1, I'm going to be at the point -1, 1. And then e to the 1, right? If I put in x is 0 here, e to the 1 is actually going to be e. And so if I've got a point of 1 there, and then a point of 2 there, and a point of 3 there, I'm going to put a point here like 2.8-ish, or 2.7-ish, and call that e. And then my graph here is going to grow exponentially. And that's a decent sketch of e to the x plus 1. If I want to verify that, I can go to my calculator, because remember I am letting you use a calculator on this final. And I can type in second and hit natural log to get in my e to the x, and then put in x plus 1. I'm going to go to my window, and I'm going to go -10 to 10 on my x, but this time a little prior knowledge or a priori knowledge lets me say, hey, wait a minute, I really don't care about negative y values. So I'm going to go like -1, so that's not off the screen. And then in the positive direction, actually, because of the exponential growth, this thing could get huge. So I'm going to let it go up to like 20. It's definitely going to go off the graph before it gets to 10, but we'll see what happens. That graph, you see it's still definitely going way off the graph before it gets to x equals 10. But as I shift up there, you can also see that that horizontal asymptote at y equals 0 is definitely being approached as I go left. And if I keep zooming in here until I get that 1, the -1 corner here on my grid, you can see that I do pass through the point -1, 1. And you can see that my y-intercept is somewhere in the 2.7-ish, 2.8-ish range, which is good because it should be e. Hope that helps us incorporate this new type of base graph into our graphing by transformations or sketching by transformations.